Hi, this is Nathan Tintle. In this learning goal video, we're going to talk about how the results from a test of significance tell you something about whether a null hypothesis value of the parameter is in or not in the confidence interval, and vice versa. We will use the cancer sniffing dog data set to talk about this learning goal. We could test the null hypothesis that Maureen's long-run probability of making a correct choice is 70%. Then the alternative would be that it's not 70%. If you do that test, you obtain a p-value of approximately 0. This means that 70% is not a plausible value for Maureen's long-run probability of making a correct choice. This tells us then that 70% will not be in the confidence interval, because a confidence interval is a range of plausible values for the population parameter. So because that p-value is small, we can reject the value 70%, meaning it's not going to be in the confidence interval, because a confidence interval is a set or a range of plausible, believable values for the population parameter. Here's the key idea. If the significance level is 5%, then when you do tests and you get a p-value less than 5%, the value you've tested, the null hypothesis value, will not be in the confidence interval. If the p-value is greater than 5%, then the parameter value will be in the 95% confidence interval. Looking at this from the other perspective, if you have a 95% confidence interval, then you know that any values in the interval, if you did a test of significance on those values, will yield p-values greater than 5%, whereas values that are not in the confidence interval will yield you p-values less than 5%. Now, if you're doing this in practice, you may see some small differences if you're using simulation, because the p-values and the confidence intervals you get from simulation vary a little bit depending on the number of simulations that you do, and just vary a little bit from person to person. But overall, this rule will hold true. Now, some students ask at this point, hey, are confidence intervals better? They're telling me more about the location of the interval. And while they are telling you more about the location of the interval, they are not telling you about the strength of evidence against specific hypotheses. So statisticians use both confidence intervals and tests of significance to tell us about both location and strength of evidence against specific parameter values.